A particle P starts from rest at O and moves with variable acceleration a meters per second squared, where a is equal to t upon 5 for the first 5 seconds, and then a is equal to t upon 5 plus 10 over t squared from that point onwards. T is measured in seconds. Show that the speed of p is 2.5 meters per second when t equals 5 and 11 meters per second when t is equal to 10. Well, we know that velocity is the integral of acceleration with respect to t. And if we deal with this part first, then we know that the expression for acceleration is this one. So we're doing the integral of t over 5 dt. So that is going to be t squared upon 10 plus a constant. But we're told up here that we start at rest at O. That's giving us both that x equals 0 and v is equal to 0 when t is equal to 0. And so if v is equal to 0 when t is equal to 0, that means that c is equal to 0. So v is just t squared on 10. So what is v of 5? So v of 5 is going to be 5 squared over 10, which is 25 divided by 10, which is 2.5 or 2.5. And so that is as required. Now, let's think about what happens from then onwards. The acceleration changes to this expression here. And the boundary conditions are that when t is equal to 5, v is 2.5. So, the first part was looking at t between 0 and 5. And now what we need to do is look at t from 5 onwards. So let's just write that as t is greater than or equal to 5. Okay, so v would be equal to the integral of t upon 5 plus 10t to the negative 2 dt. And that is going to be t squared on 10, take away 10t to the negative 1, so 10 over t, plus a constant. You can go through that more slowly if you want to, just to verify that for yourself. Now we know that v is equal to 2.5 when t is equal to 5. So what does that give us? So 2.5 is equal to 25 over 10, take away 10 over 5 plus c, and if we rearrange that a bit, notice that these two will just cancel out. That gives us c is equal to 2. So v is going to be t squared on 10, take away 10 over t plus 2, and we wanted v of 10. That is going to be 10 squared over 10, take away 10 divided by 10 plus 2. So that's 100 divided by 10 is 10, take away 1 plus 2, which is 11 meters per second as required. Okay, so now we want to go on and show that the displacement of p from O when t is 10 is 43 1/3 take away 10 log 2 meters. So I think we should start as we did before in the region where t is between 0 and 5. And our x then is going to be the integral of velocity. So that would be t squared over 10 dt. and therefore x is going to be t cubed over 30 plus a constant. But we were told back at the beginning that x equals 0 when t equals 0. So x equals 0, t equals 0. Substituting those in implies c equals 0. I keep saying substituting in because in this case it is, but if you had some sort of expression that was maybe a cosine rather than just a t cubed, cosine of 0 is 1. So the constant isn't just necessarily 0 because x is 0 when t is 0. X equals 0 when t equals 0 in this case. And that gives us that x of 5 is equal to 5 cubed over 30. Sorry, yes, so x would be t cubed over 30. X 5 then is 5 cubed over 30. So that is 125 divided by 30. So let's just stick with that for the moment. And then let's move on and look at the next part where so with t is greater than or equal to 5. This was a less than, not just a less than or equal to there. Okay, t is greater than or equal to 5. And so our x would be the integral of t squared on 10, take away 10 over t plus 2. That was from before. So that's going to be t cubed on 30, take away 10 ln t plus 2t plus a constant. We know that x is equal to 125 on 30 when t equals 5. So 125 on 30 is going to be equal to 125 on 30, take away 10 ln 5 plus 10 plus a constant, which gives us that our constant is equal to 10 ln 5 take away 10. So that means that x is t cubed over 30, take away 10 ln t plus 2t plus 10 ln 5 take away 10. And we want x of 10, which is going to be 10 cubed, which is 1000 over 30. Take away 10 ln 10. And I just noticed I got a sign wrong here. That would be a plus just there. And then we've got plus 20 plus 10 ln 5 take away 10. Well, 1000 divided by 30 is 33 and a third. And then if we look at the numbers here, I've got to add 10 to that. And then using log laws, we can put these together as 10 ln 10 divided by 5. And I think we now have the answer. I did say that was 10. I didn't write the 1 down. And so that is 43 and 1/3. Take away 10 ln 2, and that would be in meters. And that is the expression that we were aiming for.